Alright, so now we're moving from solving linear equations to solving linear inequalities. So here we go.
Today's objective is to graph two variable equalities.
Here's your vocabulary for linear inequality. It's just an inequality whose graph is a line. The line is the boundary that separates the coordinate plane into two areas. They're called half planes. And one side is always going to be shaded and the other side is not. And the shaded side contains all your solutions, or the ordered pairs of the inequality. And this is basically, I have written down what a solution of an inequality is, and here's an example. So a solution makes the inequality true. An ordered pair that makes it false is not a solution. So pause if you need to and write this information down. Alright, here are the 5 steps I've developed or came up with over time on how to solve a linear inequality. First thing, decide what type of line it's going to be. Is it going to have open dots and a dashed line, or closed dots and a solid line? Second step, put your inequality in slope-intercept form. Step 3, graph the line. 4, test point. You're using a test point to decide what side of the line to shade on. And I'll show you a couple of alternatives, something with my arms that it's better to see, that we'll do that in class, and I'll show you something to do on the calculator. So those are my 5 steps to solving a linear inequality. Okay, so here's our first example, and we have to graph this linear inequality. First of all, based on the inequality, which is greater than or equal to, I need to decide what type of line it's going to be. So since it's the greater than or equal to, that means I have closed dots and a solid line. Alright, step 2, put it in slope-intercept form. And also, you can, if you want to, use your x and y intercepts, find those, and graph it from that. If you want to, we'll give that a shot in class. But right now, we're just going to do slope-intercept form. So first of all, to do slope-intercept form, I need y by itself, so I'm going to move the x over here. So I am subtracting 2x from each side. So that gives me 3y is greater than or equal to. And remember, this negative 2 has an x attached to it, and the 12 does not. So I cannot put those two together. All right. Next, in slope-intercept form, I want y by itself, but I got a 3 in front, and that 3 means multiplication, so I undo multiplication with division. And if I divide, I have to divide every term all the way across by that same number. So now, I am in slope-intercept form. All right, now I'm going to graph my line. So my starting point is my y-intercept, and it's on the y-axis, and it is at 1, 2, 3, 4. So that's my starting point, and then from there I use my slope to plot a couple more points. The negative 2, that's my rise. That means I fall down 2, and this is my run 3. Whoops, I fall down 2, and I run over 1, 2, 3. So there's another point. And I can use my slope again. I fall down 2 and I run over 3. And if I connect those dots, and remember, solid dots, solid line. So this is my line. All right, step 4, I'm going to choose a test point. And that's an ordered pair that is not on my line. So I'm going to choose, I'll just choose 0, 0 here, and I'm going to substitute that in. So my x-coordinate is 0, and I'm substituting in my y-coordinate of 0. Alright, and when I simplify that, 2 times 0 is 0, 3 times 0 is 0, 0 is greater than or equal to 12. Alright, now I need to know, is that a true statement or a false statement? Is 0 bigger than 12? That is false. 0 is not bigger than 12. So this point, 0, 0, was on this side of the number line. So since that statement was false, I have to shade my number line on the opposite side. If this statement would have been true, I would have shaded on the side of the line that had the point. So there's one example. All Alright, so step 1. What type of line? Well, my inequality is greater than. It's not greater than or equal to, so that means I have a line when I graph it that's going to have open dots and the line's going to be dashed. Next step, put it in slope-intercept form. Or if you want to, you can use your x and y intercepts. It's up to you. I'm going to do the slope-intercept form. So first of all, I move the 3x over. So I'm subtracting 3x from each side, and I get negative 2y is greater than. Oops, and that is supposed to be an x there. So, and my 3x and my 8, I can't combine them together because the 3 has an x attached to it and the 8 doesn't, so I'll just write them separately. Then I'm going to, I have a negative 2 in front of that y. That means multiplication, so I undo my multiplication with division. And I have to divide every term all the way across. I can't leave out any of the terms. Alright, and then I have y, and I divided by a negative number, so I've got to flip this in the other direction. My negatives cancel out, so I have 3 over 2x, that's my slope, minus 4. So now I'm going to graph this. So my y-intercept is negative 4, so I'm going to go down 1, 2, 3, 4. Whoops, 1, 2, 3, 4, and at negative 4 I have an open dot. Remember, I have open dots. Then I'm going to use my slope, my rise over my run, so I'm going to go up 3, 1, 2, 3, and run over 2, 1, 2, and I have another open dot. Then I can use my slope again. I run up 1, 2, 3, and run over 2, and another open dot. And then I connect my dots by a dashed line. Alright, now I'm going to choose a test point. That's step number 4. And I'm going to choose this point right here, which is 6, 0. It doesn't matter what point you choose as long as it's a point not on the number line. So this is my x, this is my y. I have an x coordinate and a y coordinate. I'm going to substitute them in. So 3 times 6 for my x minus 2 times 0 for my y is greater than 8. And that cancels out, and I have 18. 3 times 6 is 18, is greater than 8. Alright, so now I've substituted this in, and did this give me a true or a false statement? Last time I got a false, but look here, this time 18 is greater than 18, so this is true. So because that is true, I shade on the side of the line that has that point. So if you get a false statement, you shade on the opposite side of the line as that point. If you get a true statement, you shade on the side of the line that has that point. Crap. Alright, now I'm going to show you how to graph inequalities that have basically just one variable. So I have an inequality, y is less than 3. So first of all, what type of line? Same steps. This is going to be a dashed line, open dots. And all I'm graphing is the line y equals 3. So what that means is I have a line that cuts through the y-axis where y is 3. So what it looks like is a horizontal line with a slope of 0. And this line is dashed, so I make it a dashed line. Alright. Now when I substitute my test point in, I'll just substitute in the point, let's see, 0, 0. Alright, I don't have an x-coordinate, but I have a y-coordinate. 0 is less than 3. And that is true. So that means I shade below the line any numbers less than 3. That's basically what that shaded area is. I'm shading in all the numbers smaller than 3. Okay, my second example. First question, what type of line? So I have a solid line here. And I'm going to have a solid line going through, and it's the equation y is equal to negative, x is equal to negative 1. So this is my x-axis, and at negative 1, I have a line that has to cut through that point. So it has to be a vertical line. Alright, now test point. Basically, I want all the numbers greater than, bigger than negative 1. So all my numbers bigger than negative 1 are on this side of my line. So that's the area I shade. So that's how you shade one vertical or a horizontal line in an inequality. Alright, here's one for you to try. So let's follow those same 5 steps. And let's see if you can solve this one. Remember, the solution to a linear inequality is basically the graph of a line with a shaded area. So let's see if you can follow all 5 steps. So pause the video and restart to check your work with mine. Alright, so compare my answer to yours. Did we come up with the same thing? If not, we'll discuss it in class. Alright, final thing. We've done a number of inequalities and we've came up with the graph. Let's see if you can work backwards. Here's the graph of an inequality. See if you can figure out what the inequality is. So give this some thought, write down what you think about it, and we'll discuss it in class.